want to do some problems. I have this on a PowerPoint, so you might have to bear with me a little bit. Sometimes writing on my PowerPoint causes a little bit of an issue. It's not as seamless as I would like. So I want to look at some past AP questions that you have to use Euler's method of approximation. So here's the first one. And I did try to put, can you use a calculator? Can you not use a calculator? Kind of just some basics for you. This is a pretty old question because it has 6 choices. And I am going to write on this screen so we get a chance to kind of mark this up. So here's what they have to give you. They have to give you your differential equation. They have to give you your starting point, or sometimes they refer to it as your initial condition. And then they have to tell you where are we going and how many steps is it going to take to get there. So we're starting at f equals 1. We want to get to f equals 2. And we're taking 2 steps. So if you think on your number line, we're going from 1 to 2, and we're making 2 steps, then we must be going to 1.5 in the middle. So my step size is going to be 1/2 or 0.5. So that we're going to work, especially if you can't use a calculator, you're not going to have to take a lot of steps, and they will be relatively quick and small. So the process is you start with your original y value. So your original y value is 0. So this is your x sub o, and this is your y sub o, just putting context to that equation you just wrote down. So you have your initial y value plus your step size, which is going to be 1/2, times what you get when you put your point into your differential equation. So that's where this comes. So you're going to get a slope at that point. So if I put 1, 0 in, I get 2 times 1 plus 0, I get 2. So I'm going to take 1/2 times 2, which is 1. This is your new y value. So this is basically saying now instead of being at 1, we're at 1.5, and my y value is 1. I do this every time I do an Euler's problem. Is after I do each line, I write down, where am I? What is my x value now that I took that step, and what is my new y value? So then I do it again. So I'm starting at 1 this time because that's my new y value, plus my step size doesn't change, it's still 1/2. And now I'm going to put this point into my differential equation. So I'm going to put 1.5 in for x, so 2 times 1.5 is 3, plus 1, so 3 plus 1 is 4. So we get 1 plus half of 4 is 2, so 1 plus 2 is 3. So now I'm at the point 2, 3. And I'm done actually, because the goal was what happens when I get to 2 for x. So when I get to 2 for x, I get 3. So that is my process. And again, there's a lot of little things going on. As you do more of them, they make way more sense. I promise. Okay, next one. There we go. I didn't skip one, did I? No. Okay, next one. They give you, again, my differential equation. My differential equation is x minus y. They give you my starting point. So I'm starting at the point 1, 3. We want to get to 2 with 2 steps again. You can see they do these questions so similar year after year. So again, we're going from 1 to 1.5, and then from 1.5 to 2. So we're making 2 steps. The step size is each going to be 1/2 again, or 0.5. So I'm starting at 1, or I'm starting at 1, 3, excuse me. So my y value is 3, plus my step size is 1/2, times what I get when I put 1, 3 into my differential equation. So when I put 1, 3 into my differential equation, I get 1 minus 3, which is -2. So I get 3 plus half of -2 is -1. So 3 plus -1 is 2. So now I'm at the point 1.5, 2. So I'm starting at y equals 2 this time. My step size is still 1/2. Now I'm going to put 1.5 and 2 in, so I get 1.5 minus 2, which is -1/2. So 1/2 times 1/2 is 1/4. It is negative though, so I get 2 plus a -1/4, so 2 minus 1/4 would be 7/4. And I'm actually done because that is the point 2, 7/4, and the goal is to figure out what happens when x is 2. So my answer is C. So there's my answer. Go to my next problem. So here's another way to present it. This is a more recent question. This is one where they give you a table of values for your derivative. So you'll notice you have your x values and you have your f prime. These will actually be easier because they're doing a lot of the arithmetic for you. I actually prefer this setup. They're telling you that you have this differential equation that we're just calling f prime. So instead of actually giving you an equation, they're just being very generic. We're starting at 1, 5. We are trying to get to 2. And they're telling you that we're going to do half a step. So we're starting at 1, we're getting to 2, we have half a step. So our first y value is 5, so it's 5 plus my step size is 0.5. And then my slope, my differential equation at 1, 5 would be 0.5. Now this one you are allowed to use a calculator, so if you want to grab a calculator and type in, okay, what's 5 plus 0.5 times 0.5, we get 5.25. So now I'm at the point 1.5 comma 5.25. So I'm going to take 5.25, add it to my step size is still 0.5. Now I want to know what happens when x is 1.5. What's my slope? So now I'm looking in this column. My slope is 0.4. So on my calculator, I'm going to take 5.25 plus 0.5 times 0.4, and I get 5.45. And at this point, I'm done because the goal was to figure out what I get at 2, and I'm at 2. I'm at 5.45. If you continue further, if you say, well, there's another column here, I better keep going, you will, I'm sure, work yourself into a wrong answer. They only want you to approximate at 2, so you get 5.45, and you are done. There's my answer. All right. This one's so similar to one of the ones we've already done. We have our initial, or our differential equation is x plus y. Our initial condition is 1, 2. We are making a step size of a half again. We are starting at 1, going to 2. So I'm starting at a y value of 2, plus my step size is 0.5. When I put 1, 2 into my differential equation, I get 3. So let's see. 3 times 0.5 is 1.5 times plus 2 is 3.5. So now I'm at the point 1.5 comma 3.5. So I'm starting at 3.5. I'm adding a step size of a half. And then I'm multiplying by x plus y. So that's 5. So 0.5 times 5 is 2.5. So I get 3.5 plus 2.5. And yes, you can't use a calculator here. You can do this. You get 6. And we are done. We now know that f of 2 equals 6, which my answer is C. There you go. I think this might be the last one. This is another table one. I like the table ones a lot. So this one, we are starting at negative 0.2 comma 1. And we want to know what happens when I get to, hit the answer. Okay, the answer is B. Well, let's get there though. Sorry. We want to know what happens when I get to 0.4. And we are doing smaller steps here. Now, you will definitely want a calculator for this. You can see it says calculator allowed. Our step size is only 0.2. So it's going to take a few steps to get there. So we're starting at negative 0.2 comma 1. So we have 1 plus my step size is 0.2. At negative 0.2, my y value, or my derivative value, is 0.8. So on my calculator, I'm going to type in 1 plus 0.2 times 0.8, and I get 1.16. So now I'm at 0, because I did a step of 0.2, comma 1.16. So 1.16 plus step size of a half. Now let's see what I get when I put x in as 0 for my derivative. I get 1.2. So take my 1.16 plus 0.2 times 1.2. I get 1.4. So now I'm at 0.2 comma 1.4. So 1.4 plus 0.2 times my value at 0.2 is 1.7. So I'm going to take my 1.4 plus 0.2 times 1.7, and I get 1.74, and that should be it, because now I'm at 0.4, which is what I was going for, 1.74, and as I already revealed the answer, no added drama to this one, you do get B. Oh, I do have another one. We'll keep going. I think this should be the last one. So this one, again, same idea. We have my differential. I keep doing that. I'm sorry. We have my differential equation, which is x minus y. We have our starting point. We are trying to get to 3. So that's one space up. We're doing 2 steps. So my step size is a half again. So I'm starting at 8 plus a step size of a half, times, when I put 8 in, 2 minus 8 is -6. So you get 8 plus -3, which is -5. So now I'm at 2.5, -5. So negative, or not -5, +5, I'm sorry, +5, because it's 8 minus 3. So 2.5, 5. So I'm at 5 plus 0.5. And then 2.5 minus 5 is -2.5. Oh, I might want to go to fractions. So let me write this out. So 5 plus, I know what the answer is going to be, so I just want to make sure I can get there. -2.5 is -5/2. So I get 5 minus 5/4, which is 20/4 minus 5/4, which is 15/4. We are done at that point. We have made it to 3, and we're at 15/4, and that is C. So that is how you do Eulers. It is not a very exciting lesson, but it is quick. It's easy. I like that on the AP test, they don't make you do a ton of these. I've seen some problems in textbooks where they're asking you to do 5, 6, 7 steps, and it gets ridiculous. They do tend to stick with 2 to 4 steps and sometimes give you even more information. So those are all your examples of Eulers. I hope that makes sense. I hope between that and my other video and the Barron's pages, this is clicking for you and you're feeling comfortable with it.